The task of this question is pretty easy to recognize. The equation makes it clear. We're going to need to merge these two radicals together. But there are some rules that you need to memorize to work with radicals and to add them. So let's make sure we know that. If we don't, we're going to have some trouble, but hopefully this review can help you. What I like to do is take the number and split it up into some factors. And so if I split it into 16 times 3, which is 48, I can see that buried within this is a kind of mini square root. Because 16 is 4 times 4, what I'm now allowed to do is take this pair of numbers, turn it into one number that I bring outside. So the 4 goes outside, and the 3, since it's all alone, has to stay inside. So that's how we reduce a radical or kind of manipulate it a little bit. Let's do the same thing with radical 75, because that one can be split into 25 and 3, and 25 is also a perfect square. That's going to be 5 and 5, and so those 5s can come out, leaving us with 5 root 3. And so the only way we can really add radicals is when the radical component is the same. So this is kind of like a more advanced version of adding fractions, right? You need the common denominator to be the same. This is kind of behaving in a similar way. So what would we now do? Well, we would, kind of like with common denominators, keep the denominator, or keep the radical, and then add the numerators, or in this case, the coefficients in front. So 4 plus 5 is 9. So there we go. That is our simplified version, and since they want the value of x plus y, all we've got to do is take these two numbers and add them together. So in this case, x plus y is going to be 9 plus 3, which is 12, and that is an answer. This is definitely tough. There are going to be cases where you need to memorize these rules, but in general, it doesn't come up that often on the SAT, so this is probably a low priority question for people who are kind of just getting other things wrong at this point.